Good morning. This is the SnowPod Transmission. I have been cleaning parts for a few days and scrubbing things up, making sure everything fits, and rebuilt the transmission in a very loose form, or at least just barely tucked together. So gaps like these here and this one here and this gap here, those are not real at this point. Those are just to hold things together in a way that you can see how this is put together, and so that I can take it apart piece by piece without struggling through the whole rigmarole. I have to admit that it took me many days to figure out this puzzle in reverse, even though I'm the one who actually designed it and built the damn thing. Actually, a lot of the machining was done by my friend Mike at Far West Machine. Thank you, Mike. But at any rate, I have to be able to tear one of these apart using, of course, my bare hands, but perhaps even gloved if necessary, in a snowstorm, stuck in a tent at 12,000 feet up on a mountain. There's no way you can do that unless you know each of the parts intimately and know how to deal with them effectively. If you have to rebuild one of these in the field, you're in for a lot of work, and risky work at that. So you have to know where everything goes, and you have to be able to organize your parts effectively. Quite literally, your ability to move depends upon this little device here. And so let's get started. There is a left hand and a right hand. This is the right hand side. So your view is from the front of the SnowPod, and my view is from the rear of the SnowPod. So that's going forward towards up the mountain, let's say. And we have the left-hand track and the right-hand track here. It's the opposite for you guys, but it doesn't really matter that much from a standpoint of how it operates. Each of these consists of 5 towers, 2 for each transmission and a central one to support the input power shaft. There's a 7-speed cluster here, a coupler, and then the left-hand side and then the right-hand side. And those all fit on this base here. And this is just 2 pieces of aluminum. They are bolted together with a line of 832 bolts, I believe. And if you look carefully, you can see that there's a little bit of an angle there. That's so that when it sits on the SnowPod, it sits not flat like that, but tilted up like that, and so that this back plane here is more or less vertical. So it sits at an angle roughly like that. Okay, the derailleur for the 7-speed cluster mounts right there. There's a couple of bolt holes. It actually goes in there like that. I'm not going to put that in until the very last, but I wanted to show you where it goes. It just bolts into the frame like that, and that determines the chain guide. There's a couple of brackets that go underneath. Those guys go down here. Let's see, where do they go? Here and here, I believe. And then the chain runs around this. So this is basically a set of roller bearings that guides the slack side of the chain, or the power side of the chain, actually. So there's 2 of those, and I'll put those in later. And then I have a bag full of miscellaneous parts, snap rings and springs and various adjustment bits, mostly not terribly important at this point of the process. This particular video is really focused on the transmission. So we're going to set this guy aside and no longer consider that and focus entirely on the transmission itself. It basically splits into two halves with a coupler between them, and those couplers are connected with keyways to the shaft here. You can see right there that there's a keyway there on each side, and if you can't see it, it's not a big deal. Trust me, there's a keyway there. And the same with the other side, so there's two of those are identical, and they fit in the very end of the shaft here. This is 7/16 shaft. It's a special hardened shaft that's machinable, but has a great deal of tensile strength to it. Something that Mike picked out, and I'm not exactly sure what alloy it is. And then this guy is just an aluminum coupler designed to couple those two together like so. I needed a little extra room or something. I can't remember why I wanted that. So there's the left-hand side here, and the right-hand side. It also incorporates the one support tower on this side. I want to take just that off. Okay, so there's a support tower that goes in the middle, and just a bearing in here, and then up on top there's just a 1/4-20 all thread with a feed through for the wire cables that run through the control levers here. So you'll see how those work later once I get the whole thing assembled. Then there's a 7-speed cluster here that's connected to the shaft with, again, another keyway. And we're going to take that off and set it aside for the minute. I do want to go through this 7-speed cluster here. This is the old freewheel style. But what I've done is taken the freewheel portion of it, punched it out, and then pressed in an aluminum bushing so that this is now fixed. This is no longer a freewheel. It's just a 7-speed cluster that can be driven either in forward or reverse. And then there's a key that goes in there and a little set screw at the end right there. I should get something to point with. There's a little set screw right there to keep it in the right location, and that works fine. I'll set that aside. Okay, so now we're down to the two 7-speed or two gearboxes for the left and the right, and I'm going to set aside one of these and focus just on the one side. Let me pull up. When you're dealing with transmissions like these, you tend to have to take them apart and put them back together, and take them apart and put them back together repeatedly. So everything has to be a slip fit, just a little bit tighter than easy. As long as you can push it on with a good solid force, gentle hand force, then you're okay. If it slides on and is sloppy, that's not good. So the tolerances have to be fairly good. What I found is that when I took this apart, all of the keyways had buggered a little bit, and the shaft had dinged and warped a little bit. There was a bit of rust on it, so it required a considerable amount of work to actually get the shaft back in shape so I could slide things on and off of it with relative ease. The reality of the matter is I probably spent a good 10 solid hours out here manipulating this transmission and cleaning it up and deburring it and making sure everything fit like it's supposed to. and so that I can get it apart and back together on camera here, so you can actually see how it works with relative ease. So let's do that. So first things first, well, what is first? That's a good question. I had to figure that out. It was 20 years ago I built and designed this thing, and I had forgotten a lot of the details, but they came back to me pretty quickly. So I'm going to take the two towers off. Okay, so there goes one tower, and you can see that that's a tight fit, and so there's one guy, and I have the 832 screws to go in there, and then on the other side we have another tower with a 7/16 shaft bearing in it, and then a small brass bushing that bangs up against this guy here and pushes on this shaft right here. Okay, let me get my hands out of the way so you can see that lever pushes on that shaft right there. It actually pushes on this bearing, which is up against this, a snap ring that fits right there, but it pushes on that. Now, if you look very carefully, and I'm probably going to have to zoom in here to do this, but you can just barely see there's a pawl right there. That pawl will rise up and lower down as we push in. So this is essentially what activates the pawl right there. Okay, on the other side, there's another lever here, and it activates its own pawl system. So this side comes off relatively easy, and I'll try to keep these in some sort of order. So that goes first. Now this part has, you can see inside here, there's a pawl system ring here. This is from a Sturmey Archer hub, and you can see that the lever here that pushes, that swings back and forth there, and I'll show you what that pushes on in just a second here. But that operates the mechanism that allows the pawls to engage or disengage this pawl ring here. And again, this is from a Sturmey Archer bicycle hub. We tore those apart, cut this off, and very hard steel, so it had to be cut off and ground down to a smooth surface, and then pressed into this aluminum housing here. And those have to face a certain particular direction so that the pawls will do what they're supposed to do. The other side of the transmission, the left-hand side over here, this guy is just the opposite. It's essentially the mirror image of what I'm showing you here. So anyhow, that's one system there, and you can see that there's a spring, and those then, I'll bring that up so you guys can see it easier. Stop. If I push in on that guy, that pawl will rise up. There's a little spring, they're spring loaded, and when they spring up, they engage the pawl ring and fix this guy with respect to that pawl ring. And so it holds this cage here. If the lever is out, then this pawl goes down and misses the pawl ring and is free from that. And there's two of these in each of the transmissions. So this goes on one side, but to get this off, I actually have to take the other side off first. Okay, so here is the output shaft, or output gear, and that's just a simple bicycle chain ring, 18 teeth? You count them. It's the 3 dimple kind. There's 3 dimples in here, and then there's 3 dimples machined into the outer ring here. That fits on there, and then there's a snap ring groove right there. Snap ring groove right there that holds it all together. And then that mounts on this guy here. Okay. All right, now I have to work these apart just a little bit. There we go. Okay. That comes apart. Okay, you can see that there's another pawl ring in here. Okay, right here, and that pawl ring sits so that the pawls grab in that direction. This one also sits so the pawls grab in that forward direction from the top going to the front. So both pawl rings in the right hand side are put in this way. They're actually the same direction on the left hand side, but it's a mirror image because the whole thing is shifted around backwards. So that guy there bolts onto here, and there's a bearing that fits in there. I did not install the bearing, and that fits in there. I bought new bearings for this guy. Okay, and then this guy fits in here, and okay. So now, one of the key design issues was how to push on this guy here to make those you can see that pawl a little bit more clearly now. Let me raise that up so you can focus on it, and too far, and you can see that pawl move up and down. There's the pawls up, and there's the pawls down, and I'm doing that by pushing in on that shaft right there. Okay. Now that shaft goes through the center of the main shaft, and it's held in place and pushes on the pawl shim. I have to give that a name. I don't have a name for it. Okay, so this guy here slides back and forth, and you can see that there's a little shaft that runs from left to right. When I took these apart, I forgot how I built them. I thought maybe it was a pin pressed into this. You can see it moves back and forth right there. Let's see if I can get it so you can see it. Okay, but they're actually screwed in. So I made some new ones for this, and let me take those apart. Okay, there's one. Let me get the other side. Okay, there we go. Those two are out, so now that screw or that shaft comes out of there. Let me just review these guys. They screw into here. When I do the final assembly, I don't want to lose these, I'm going to screw them back in here. Losing parts is a big no-no, especially when you're on top of the mountain. But that's the pusher for the right-hand side of this transmission. And these are made from shoulder screws. And I had to cut down the thread there. I had to cut the thread down about 40 thousandths and then cut the head off the shoulder screw, and then you can probably just barely see that. There you go. There's a little slot. Put a little slot in there using a Dremel cutoff tool in the mill. Put a nice little slot in there so I can A, remember that they're not pressed in, and B, use a screwdriver to get them together. This transmission is not the easiest in the world to assemble and disassemble, but that's the way prototypes go. You know, if I had to redesign this all over again, I would make it a hell of a lot easier, but that would require a lot of engineering to get done properly. Okay, so this guy here is the actual pusher that pushes on the pawls, and when the pawls are above this section here, they tend to want to spring out and engage the pawl ring. When they're over this section, this slides back and forth. When they're over this section, they tend to push on the pawls and brings them down, brings the pawls down, pushes on the inside to bring the outside down and disengage from the pawl ring. So that's just a piece of stainless, I believe, with brass bushing in the center that slides on and off the shaft easily. And that's kept in the out position with a spring that goes into this cage right here. And so obviously that was a custom job. I didn't buy specialty springs for that. Okay, so now we're ready to actually pull this guy apart, and this is why all right, that's a nice tight fit. That actually connects to the shaft with a Woodruff key. And you can see that that Woodruff key goes right in here. I have room for a set screw there, but you can't use it by the way the design is. You have to, there's no way to actually actuate that set screw. The pawls, if you look very carefully, are spring loaded. And so they want to pop up when this guy is pushed in. Let me see if I can get this in here. If you get it cocked even just a little bit, it tends to want to bind up. So everything has to be straight. So when it's in like that, so now you can see that the pusher is right even with the face of that, and the pawls are down. You can't see them. And if I push that back in, the pawls pop up. And that spring keeps this pusher out. And let me get it out of there. There we go. I had to work on that. That was pretty bound up in the original version. You can see on these pawls that there's right in there's a little bump, and that's what the pusher pushes on. Pushes on that guy right there. Let me see if I can get that on in the screen there. There we go. And And then there's a spring in here. There's no way in hell you're going to see the spring. There's no way in hell I'm ever going to get a picture of it. Let me see if I can. No, there's no way in hell I can actually get. I can barely see the damn springs with my own eyes, much less try to show them to you on the camera. But they're shaped like a keyway and very, very tiny, and they're very, very easy to lose. I've actually taken this guy, and there's a pin that goes in here. You can see the back side. There's a pin right there that goes through the pawl, and I use a little bit of aluminized tape, duct tape, which is really handy stuff. I really love that stuff. Sticks nicely to clean metal and cleans up easily. To keep that pin in, I'll take this off before I actually do the final assembly, but that prevents me from inadvertently shaking those pins out and then losing these damn springs. I don't even think I can buy those springs anymore. This Sturmey Archer hub is still sold, but not by Sturmey Archer anymore, and I have not checked on what the status of that is. Okay, so on the other side, we have essentially the same thing. We have a bushing here, and that bushing pushes on what I'm calling the pawl pusher, and this one doesn't have a bushing in the middle of it. It's a little bit different in design. Another spring, okay? And so those two are essentially the same, and then another cage. Okay, now we're ready to take off this guy, and let me get this off of here. Okay, it's going to come off as one unit. It seems like it wants to come off as one unit. Oops, I forgot there's also a big washer that goes on the one side there. Okay, so now there we have the whole shaft with the sun gear silver soldered to it. So that's from a Sturmey Archer hub. We had to drill that out ever so slightly, I believe. It may have actually fit over 7/16 shaft, and that's why we use 7/16 shaft. 7/16 is, in my opinion, a little bit small for this transmission. I would have preferred to go to 1/2 inch, but the sun gears I could get at the time, the cheap gearing I could get at the time, was a Sturmey Archer hub, and that took 7/16 shaft, if I recall correctly. We may have actually had to grind that out just a little bit, but it's silver soldered onto the shaft in the right location. Okay, so that's essentially the drive input. Recall that this guy is keyed to this, so you know when that turns, the whole thing turns, and so this is the driven part of the planetary gear system. And that's what we want to show you next, is the planetary gear system. And that goes here. Here's, oops, shoot, I always do that. All my planetaries just fell out. That's okay. So these two guys are essentially identical in function. This one is obviously shop made. This is actually from the Sturmey Archer hub, and it's a pawl carrier and the planetary gear carrier. And here is the 4 planetary gears and their shafts, and those fit around the sun gear like so, and get that out of the way, and they all fit in this cage. So this cage represents a way to grab hold of the planetary gear system. But you can see in the inside here that there's the ring gear. Let me see if I can get the angle and light correct here. Well, that kind of shows it. You can see the sun or the ring gear here, and these guys all go in there like that, 4 of them, and then the sun gear goes in there like that. In fact, let me just put this together. That goes like that, and see if I can get one of these ring gears in here, or planetary gears in here, without totally screwing this up. Okay, there we go. That's got one. You can now see the arrangement of the planetary gear, the sun gear, the planetary gear. I can't see where I'm pointing. There's the planetary gear, and then the ring gear on the outside. And there's 4 of these planetary gears, so it's a fairly durable system. It's not going to break. And you know, it's a bicycle component, so it really is designed to take the very low speeds but high pressures that the human body can exert on mechanical devices. Horsepower in humans isn't great. We move very slow, but we actually apply one hell of a lot of force to a bicycle crank. You know, if you think about it, the average Joe Blow on his mountain bike, when he comes slamming down on his bike pedals, you know, is probably exerting a couple, 3,000 pounds of force on a 1-inch lever arm. You know, you're looking at 3,000 foot-pounds of torque. In that neighborhood, thousands of foot-pounds of torque. I obviously am pushing this with my arms on essentially a 1-inch or 1 foot long lever arm, the crank arms, and just approximately. They're a little bit shorter than that in reality. But you know, I can easily bench press 200 pounds. At least when I was in decent shape, and back when I was doing this, I didn't work on bench pressing, but I did work on, you know, pulling, rowing motion, and pushing motion, and lifting up, basically a curl motion and a tricep motion through the whole cycle range. And yeah, I could easily put you know, a couple of 100 pounds of force with both arms on a couple of 100 pounds of torque on those arms, foot-pounds. And so that translates after all of the gear. That translates after all of the gear is done into, you know, thousands of pounds of force on that chain. So it's quite, the system has to be quite durable. Well, thanks for watching. The next video will be on putting the whole transmission back together again, and stay tuned for that. I know these are a little dry and detailed for most folks, but for those of you who might be interested in this deep technical level, that's who my target audience is. But anyhow, like and subscribe if you so desire. Thanks.